So, we've talked before about solutions and how solutions are generally made up of two things, a solute and a solvent. So, a solute is going to be the thing that is dissolving. Okay? Think about like salt or sugar or chocolate syrup. You put that into a solvent, which is generally, a lot of times, it's a liquid. Generally, it's water. It's going to be dissolving the solute, and together they make the solution. So there are three properties of liquid solutions that we can talk about with that understanding. And the first one is conductivity. So salt water versus distilled water. When we look at the molecular or particle view of both of them, or in this case just salt water, we can see the salt, NaCl, breaks up or dissociates, and they break up into ions with negative and positive charges. We know water is a polar molecule, meaning it has a slightly negative charge on the oxygen end and a positive charge on the hydrogen end. So the negative side oxygens are going to be drawn to the positively charged sodium ions, as we can see here, and the chlorine ions, which are negatively charged, are drawn to the positively charged hydrogen sides, right? So they kind of form little packs, and they cluster up together. When this happens, we have charges being attracted to or drawn to other opposite charges. And this is going to make it extremely conductive. Because when we have more ions in it, we can create a current. Right? We can create an electrical or conductive current that allows electrons to travel through a solution. So salt water is much more conductive than distilled water, which is just pure water molecules. Water molecules on its own are also conductive, just not as good as it. So generally, when something happens or passes through a water current, it's actually the things in the water, the solutes and the ions, that are making it so conductive. Our second one is the freezing point. So water's freezing point is 32 degrees Celsius, but when we place salt in it, and we create salt water, the freezing point lowers to about 28.4 degrees Fahrenheit. And you'll typically see salt trucks when it's snowing to basically allow the ice to melt, make it easier for the ice to melt. And that's because the freezing point can actually go down. The solution, now made up of water and salt, has changed. And with a lower freezing point, the ice can melt. Okay, so basically we can make it more difficult for water to freeze. And we can see in our molecular view, just kind of solid water, we have ice. It's a very crystallized structure, which has a repeating pattern. Right, we can kind of see it's got that hexagonal shape. Liquid water is more fluid, and then gas water is bouncing around. It's got that kinetic energy going in the atmosphere. Right, so this is ice. Solid water generally creates this crystallized pattern, and between the water molecules we have hydrogen bonds, where the negatively charged oxygen sides are drawn to the positively charged hydrogen molecules, and they form hydrogen bonds. They're not extremely stable. They actually can break pretty easily, but it does keep it in that crystallized or contained structure. Our third property is our boiling point. So if you have a car or if you're driving, you probably have heard of antifreeze before. So antifreeze is a coolant that you place in the solution. So engines need to be running. They need to keep driving the engine to allow it to continue to run. So what the antifreeze does is basically lowers the freezing point. Antifreeze, we can kind of figure that, but it also increases the boiling point. And what that does is it allows for the solution, in case it gets really hot out, when that starts to happen, the water can start to expand or compress based off of, if it's boiling, it's going to start to expand. If it's freezing, it's going to start to compress and then expand. So we really want to keep the solution from freezing or boiling so that we can kind of keep it in more control. So antifreeze creates a solution that increases the boiling point. All right, in our next video, we'll be talking about solubility and basically how we can find saturated solutions.